Hi there, Mr. Sutton here, bringing you the BC Calculus 516 Extra Practice Number 1 solutions on integration by partial fractions. For this problem, I'm trying to find the antiderivative of 1 over x minus 1 times x plus 2. Now, for this one, since there's no other way to simplify this fraction and I've got unique linear factors, I'm going to try partial derivatives. So I'm going to split my fraction of 1 over that stuff into a over x minus 1 plus b over x plus 2. And then I'm multiplying everything by my denominator down here, x minus 1 and x plus 2. I've got 1 on the left side. On the right side, I've got, this is going to be a times x plus 2 because the x minus 1s are canceling. Over here, the x plus 2s cancel, so that's just b times x minus 1. And now I'm going to try to solve for a and b by picking convenient values of x. So to get a, I need to get rid of b. So I'm going to let x equal 1. And if x equals 1, well then this b term is going away because I've got b times 0. So I'm going to have 1 equals a times 1 plus 3, or 3a. So then a is going to be 1/3. Next, to get the b value, I'm going to plug in an x value of negative 2 to get rid of a. So if I do that, I've got 1 equals, and now this is going to be b times negative 3, so negative 3b. So then I have b equals negative 1/3. Plugging that in inside the integrand now, splitting up that fraction, we've got 1/3 x over x minus 1, and then we're going to have minus 1/3 over x plus 2 dx. Now I'll take our antiderivative going left to right. So we've got 1/3 ln absolute value of x minus 1 minus 1/3 ln absolute value of x plus 2. And of course, don't forget your plus c. But now you might notice this doesn't look like any of the answer choices, so that means we have to simplify the logarithm to match one of the choices. I'm going to start this process by factoring a 1/3 out from the first two terms here. So then I essentially have ln of x minus 1 minus ln of x plus 2. If I'm subtracting logs, I can divide the stuff inside them, the arguments inside. So I really have ln absolute value of x minus 1 over x plus 2, and I still have that plus c kicking around as well. So that's going to be answer choice A. For this problem, I want the antiderivative of this rational function. Now, it doesn't look like I can really cancel anything out here, and substitution's probably not going to work very well, but I do have these unique linear factors in the denominator, so I can try using partial derivatives. So I'm going to turn this fraction into a over 1 minus x plus b over 3x minus 5. And then multiplying this whole equation by this 1 minus x, 3x minus 5 term here, I'm just going to completely cancel out the denominator on the left, leaving me with 1 plus 3x. On the right, the 1 minus x cancels, so I've got a times this factor, 3x minus 5. And I also have plus b times the 1 minus x, since the 3x minus 5s are canceling over there. Now I need to figure out what a and b are. So I'm going to pick a value of x that cancels out each of these letters, and that'll allow me to solve for the other one. So if I want to get a, this is the easier of the two. If I pick an x value of 1, that's going to be b times 0, so that's going to make b go away. Plugging in 1 on the left side, I've got 1 plus 3, so 4. On the right side, I've got a times essentially 3 minus 5, so that's negative 2a. And then solving for a, I get a equals negative 2. All right, I'm going to do it again. Now we got to get the b value. So I need something that'll cancel out the a over here, that'll zero out this factor next to a. Well, if I add 5 and divide by 3, I see that a factor, or an x value of 5/3 is going to make this zero out. So I've got 5/3 getting plugged in on the left side. That's 1 plus 3 times 5/3. Well, the 3's cancel, so that's really 1 plus 5, or 6. The a cancels here because this is just a times 0 now. Over here, I've got b parentheses 1 minus 5/3, so that's going to be negative 2/3 b. And now multiplying to get rid of the 3 here, I've got an 18 over here. Divide that by negative 2, that's going to be negative 9 for my b value. Plugging all that back in now, splitting my fraction up inside the integrand, I've got negative 2 over 1 minus x. And then I have plus 9, or actually minus 9, over 3x minus 5. Now taking my antiderivative, and I've got to be careful when I do this because these inner functions here, I've got 1 minus x, I've got 3x minus 5. These are linear functions that have a derivative that's not just 1. The derivative down here is negative 1. Derivative of this inner function is 3. So I'm going to have to divide by those when I take my antiderivatives with ln. This first one then, I'm going to have negative 2 ln of absolute value of 1 minus x divided by the tail of negative 1. So that actually becomes a positive 2 ln 1 minus x. And then over here, I'm going to have to divide by 3. So I'm going to have, instead of 9, I'm going to have 3 ln absolute value of 3x minus 5. And does that match any of my answer choices? Well, let me put a plus c on the end. How about now? So I have 2 ln 1 minus x, and I have a minus 3 ln 3x minus 5. That looks like the very first answer choice, A. For this problem, for p-values between 0 and 100, I want to know which of the following is an antiderivative of this rational expression. So there isn't really much I can do to simplify this. All I can really do is factor it and try to use partial fractions to get to the bottom of this. So I'm going to write this as, let's see, 1 over p parentheses 100 minus p. And then I'm going to try to split this up with partial fractions. So I'm going to say that this equals a over p, that's my first factor, plus b over 100 minus p. So now we're going to multiply by this p times 100 minus p term here. That'll give me just 1 on the left side because we're multiplying something by its reciprocal. And then on the other side, the p is going to cancel, leaving us with a times 100 minus p. And over here for the next fraction, the 100 minus p of this part cancels. So that just leaves us with b times p. Now I need to figure out the values of a and b so I can split that fraction up. All right, well, if I pick a p-value of, I'm going to get rid of b here, so if I pick the p-value 0 to plug in, that just gets rid of b, and now I just have 1 equals 100 times, or a times 100 minus 0, which is just 100 times a. That means that a has a value of 1 over 100. Now to get the b value, I'm going to plug in something that gets rid of this a term. So if I pick the p-value 100 and plug that in, I have 1 equals just 100b. So that means that b also has a value of 100th. All right, so I'm going to make an integral now because I really wanted to take the antiderivative of this thing, but I'm going to split it up inside my integral to write it as 100th over p plus 100th over 100 minus p. And at this point, I'm going to go ahead and take the antiderivative. So I've got 100th times ln absolute value of p. And then for this next part here, I have to be a little bit careful here because my inner function has a derivative of negative 1 rather than the 1 that I had over here. So I'm going to have 100th times ln of 100 minus p in absolute value, but I'm going to have to divide by negative 1, the tail of this thing. So that's negative ln, or negative 100th ln 100 minus p. And now looking at my answer choices, and I just added a plus c, although they didn't have them in the answer choices. They said an antiderivative, not the antiderivative. So it looks like this is closest to answer choice A. Now, if you're wondering where the absolute value went in this one, they told us up here that p had a value between 0 and 100. So if p is between 0 and 100, there's no way that you're going to be plugging 0 or something negative in for this p right here, into this ln. And this ln also, if you're doing 100 minus something between 0 and 100, again, you're not taking the ln of 0 or a negative number. So that's why we didn't strictly need the absolute value symbols when it came time to pick the answer. For this problem, I'm trying to take the antiderivative of this expression. Now, it's tempting to factor this out and then try to use integration by partial fractions, very tempting, but you should always be looking to see, is it possible to do this an easier way? For example, if we use substitution, would things work out here? Well, it turns out they would. You kind of have to think ahead a little bit to see what's going to happen, though. If you choose your u value as x squared plus 2. That's going to be du equals 2x plus 2 dx. And this is something that if you factor out a 2, you're going to be able to cancel out this x plus 1 up here, which is going to solve most of your problems on this. And it's already a definite integral, so if you can avoid doing integration by partial fractions on one of these, it's always a win. So moving on with my substitution, I'm going to divide by 2x plus 2. And I'm also going to have to turn these x values into u values. So if x equals 1, then u is going to be, 1 squared plus 2 is going to be 3. And if x equals 2, 2 squared plus 2 times 2 is going to be 8 for my u value. So now rewriting this with u's, we've got integral from 3 to 8 of, this is still going to be an x plus 1. Down here we've got u, and I'm going to write this as du over, and then I'm going to factor this, 2 parentheses x plus 1. So basically what I had here, but in a format that I can now cancel out with the x plus 1. So those do end up canceling. We end up with 1/2 times 1 over u, or u to the negative 1, either way. And now we can take the antiderivative of that, which is just 1/2 times the ln of absolute value of u, evaluated from 3 to 8. And now plugging in 8 and 3, I've got ln of 8 minus ln of 3, all over 2 if I divide by 2 instead of multiplying by 1/2. And that's going to give me answer choice B. For this problem, I'm trying to find the definite integral from 1/2 to 1 of this rational expression. Now, there isn't really much I can do to simplify this. I can factor the denominator into x times x plus 1. That's not going to help me cancel out anything in the numerator. However, I can use this to do some partial fraction magic. So I'm going to try integrating this with partial fractions now. So I've got a over x plus b over x plus 1. And then multiplying everything by x times x plus 1, I'm going to have x plus 4 on the left side. And over here on the right side, the x's cancel, leaving me with a times x plus 1 plus b times x, since the x plus 1s are canceling. Now I have to figure out what a and b are. To get a, I'm going to pick an x value that gets rid of b. If I plug 0 in for x, that's going to do the job. So I'm going to have just 4 on the left side of this equation equals, well, this is just a times 0 plus 1, so just a. So we find actually right away that 4 equals a. Cool. Let's go on and find the b value now. For that, we need to get rid of this a term by plugging in an x value of negative 1. So if I do that, I've got negative 1 plus 4, or 3, on the left side of the equation. A is gone. We've got b times negative 1, so negative b, which means that b actually equals negative 3. All right, now I'm going to split up my fraction and my integrand using my a and b values that I just found. So I'm going to write that fraction as a over x, so that's 4 over x, minus 3 over x plus 1 dx. And now let's go through and take our antiderivatives. This is going to be 4 ln absolute value of x minus 3 ln absolute value of x plus 1, evaluated from 1/2 to 1. So there's a lot of ways to do this problem. This is just going to be kind of a mess no matter how you do it, but we're going to simplify it as far as we can go, just for the sake of doing it. So we've got all of this stuff with 1 plugged in. So that's 4 ln of 1, and we've got minus 3 ln of 2, essentially. And then we've also got, we're going to be subtracting all of this stuff with 1/2 plugged in. And now I'm going to go through and clean this up just a little bit. Now, if this is a free response problem on the AP exam, you could stop here and be done with it. But again, you often have to match these on multiple choice. So let's see what this simplifies to, get some practice with our log rules here. So 4 ln of 1. Well, ln of 1 is 0. So this is just 0 for this first term. We have a minus 3 ln of 2. We're going to have to do something with that. Moving on now, this is minus 4 ln of 1/2. And over here, we've got, let's see here, this is going to be minus, so plus 3 ln of, this is going to be 3/2 inside here. Next thing I'm going to do to merge all these logs together, I'm first going to pop in these coefficients as exponents. So this is going to be ln of 2 to the negative third minus ln of 1/2 to the negative fourth, or actually I'm going to be adding ln of 1/2 to the negative fourth. And over here, this is going to be plus ln of 3/2 to the third. So putting all these together, I've got 2 to the negative third, so that's 2 to the third in the denominator. I've got, let's see, 1/2 to the negative fourth. That's essentially 2 to the fourth in the numerator. And here I have a 3 to the third and a 2 to the third going on. So here's all of that stuff multiplied together. So I've got, let's see, 2 to the sixth down here, 2 to the fourth up here. So that means we really have a 2 squared down here when the dust settles. So 3 cubed over 2 squared, that's 27 over 4 inside the ln. And that's about as simplified as this is going to get.